Hello, so this is my attempt to create an animation of a circle and a sine wave for the first month of the TMiP Animation Generation Collaboration. So I'm going to be working using LaTeX and TikZ because from having written lots of papers and doing lots of work on chalk dust, I've got very well practiced at making figures in TikZ. So let's get started. So I've opened up a blank document and I'm going to do the standard way that you start LaTeX documents. I'm going to do it as an article. I'm going to begin document, end document, and let's just put some text in there. Then I've got a second window here where if I do PDF LaTeX frames, we can make a PDF. Then I can open up here so I'll be able to see what I'm doing as I go. The first thing I'll do is I will use package geometry, which is a package that lets you change the size and shape of the paper and change the margins. So let's do left equals 0 point, right equals 0 point, top equals 0 point, bottom. So let's have no margins on the paper, and I think it's paper width. Let's go for 3 centimeters and see if that works. There it is. Okay. I've got to do paper height. Put a new line in here so that wraps around. Paper height equals 3 centimeters. I imagine I'll want to adjust those later to make it slightly, in fact, it's going to be wider than it is tall, so let's make it, let's for now make it 10 centimeters by 3 centimeters. Let's zoom out so I can see the full page. Okay, so we'll have a gut drawing in here. Let's pop a no indent before here. Later, I guess I'll look up how to properly remove an indent, but that'll do for now. Second thing I'm going to do is I'm going to use package TikZ because I'm going to use TikZ to do all the drawing. So let's put our first TikZ picture in, and let's put something in it. Draw 0, 0 circle to 1 centimeter. So that should create a circle where the center is at 0, 0 and the circle is 1 centimeters wide. And let's, in fact, if we make it 1.44 centimeters, 1.49 centimeters, that should be enough. Given the paper is 3 centimeters tall, that should be enough that we have space for lines. I'm then going to play with some settings here. If I do line width is 1 point, what does that look like? That's probably quite good, but it's gone too big now for one page, so we can make that slightly smaller. There we go. Then I think if we're going to put a point on this circle moving around, we probably want to actually have some space around this circle. So let's, in fact, let's clip the whole image so that the borders are always going to be the same. So if we go from, I don't know what X is going to be, but I know what Y is going to be. So we go from, what's half of 1 point? Oh, no. So we go, it's 3 centimeters tall, so we go from minus 1.5, rectangle, something 1.5, and in the Y direction, I guess we want to also go from minus 1.5 because it's going to be as wide as it is tall, and because I've made it 10 wide, the easiest way to do it here is just add 10 and add 3, and it can work out for us how that would be. Then if we make this 1.4, we get our circle with a little bit of margin, so we can put things around the circle if we want to do it that way. Let's put a smaller circle in the center. And let's change that to fill. So we have a dot in the center because that probably is nice. It's still quite big. Let's turn it to 0.03. There we go. We've got a dot in the center to mark the center of our circle. So our circle is centered at 0, 0. And we've got a circle that is 1.4 wide. It's going to be so much easier if I adjust this to be 1. So let's... No, we'll work with 1.4. That's fine. Because otherwise it's going to all be too small. The lines will be too thick. Okay, the next thing we want to do is we want to put a horizontal line across the circle that we're going to measure the angle from. So let's draw, we'll put it under this, do it dashed for now, a line from 0, 0 to 1.40. We have a dashed line there. That looks very ugly because I've not yet done line cap equals round, line join equals round, which are my two hacks for making TikZ pictures actually look nice. There we go. And I think that's okay for now. I'll play with styling in a minute maybe, but that looks fine for now. Then I want to do an angle to another point. I'm wondering whether I want to put a point. I guess I don't need to put a point on the edge of the circle where it starts there, but we'll put a point on the edge of the circle. So let's fill, let's make it red for now. And well, let's work out if we need to import any packages to do this. If we do cos 45, wait, let's not do 45 because that's too easy to get wrong. Sine 60. The radius is 1.4. Oh yeah, circle 0.03. So that should draw a red circle there at an angle of 60 degrees. In fact, we can also draw in red. Let's make it dashed. Maybe not dashed actually, probably solid is better. A line from 0, 0 to that point. So we have a line from there, and this should go underneath these, so that the point in the center is on top of that. But the point wants to go on top of the circle, so like that. That looks nice. Then I guess it would be nice to show an angle. So we're going to draw from, let's try 0.40, an arc. So that starts from 0, goes to 60 with a radius of 0.4. So that should do a little angle for us there. Nice, and let's put that underneath everything. So it's underneath the red line. That looks good. Now, in order to animate this, the way I'm going to do it is I'm going to make a page in the PDF for each frame of animation, and then afterwards write some Python code to convert these into PNG images, and then put those, stitch those together into an MP4. So essentially what I want to do is I want to copy and paste this whole lot here and make another version of it with like 62 degrees. And we're going to get two versions of it there. I've missed some more 62s. Like that. Obviously that would be ridiculously time consuming to copy this thousands of times, so I'm going to make a command that we can use to draw this that takes one input, which will be the angle. And I'm just going to document the inputs so I remember what I was doing. Then if we copy all of this into here, replace 60 with #1, which will be the first input. what we can then do now is do frame 60 and it should look the same. Nope. Frame is already defined. A frame for animation frame. Undefined. Okay, I've done something very wrong. I see. Okay, that needs to be round brackets, not square curly. Needs to be curly brackets, not square brackets. So that now looks the same, and then I can delete all of this and put A frame 62. Maybe like that, so it goes onto a new page. Yep. So now we can create all the different frames like this. Let's work with, if we put this one at 100, and I'll do a final frame at 320, that's enough for me to look at for now, that I can see that I'm doing the correct thing while making this. And then we can go back later and put in a frame for every 2 degrees or something that we'll actually use in animation. We'll work out the frame rate and how quickly we want the animation to go at the end, but we can for now do this. So what we then want to do is we want a point traveling along that shows kind of that goes consonant with the angle, and then we want a point going up and down that is tracing that's matching the height of the red point and following our point along. So let's put a point that follows the angle first. So let's do fill. So the angle is #1, but we're going to start at 1.4 plus #1. Circle 0.03. Here we do one semicolon. And the y coordinate is going to be 0, and I'm going to here divide by 180 and times 2 times pi, so that we step along as if we're doing radians rather than degrees. That looks fine, except in the bottom one we've gone off the edge. So if I make the paper wider, is that, there we go, we are now on the paper in all 3 examples. So that point is moving as the angle increases. Now we need to do a point that has the, and I'll come back and play with some colours and things at the end. So that's the first point. We now want a point that has the same x coordinate as that, but in the same y coordinate as the point going around the circle, which is this point, this value here. So if I do that, we can see that that point is now above this point. And I think at the end I can put some dotted lines in to show that this is lining up with. In fact, let's do that now. Let's put in draw. So we want to go from something to that. If we do a line from here to that, I'm going to put some new lines in here because this is going to be horrible. Dashed. A dashed line from there to there. Why does that? Oh, I see. Okay, and then it's drawing a circle then, so I need to get rid of that. That's why that point looks so much bigger than the others. That's better. And from there, we'll draw a dashed line down to this point. So that's showing which things that point is staying in line with. And actually that point should probably be another different colour. This dashed line should be underneath the red fill, because it would look nicer if the red point stays on top of it. I think I'm going to come back at the end and put some more colour onto all of these points. And actually, that dashed line just added, I'm going to make that less wide. Let's make it half a point wide, and let's make it grey. Yeah, maybe the 0.8 point, a bit wider than that. That's good. So that line looks like it's kind of in the background of everything. We could even put it behind everything. What does that look like? That's good, and then it won't get in the way. And then the important point. So this one here is the important point, I think. Let's make that green. Yeah, that point there is the important point. I'm going to make this one bigger because that's the point we want people to pay attention to. In fact, I think it would look better if all the points were bigger because they're getting sort of lost in the lines. So let's make them all 0.05. Replace all 0.03 with 0.05. That looks better. But this point still wants to be some colour. You know, in fact, I think maybe the red bits don't really need to be red. But this point should be red. Because that's the important point. And then what we want to do is that red point wants to be tracing a path as it goes. Because it should be drawing the shape of a sine curve. And because I know that, I can use that I know that in each one to just draw a sine curve. Up to that point. So we're going to draw plot variable equals x, domain equals 0 up to 1. So it's from an angle of 0 up to where we are. Samples equals, let's do 1,000, 100. And we'll see if that looks smooth. If it doesn't look smooth, we can increase that later. And then we give it a point. So it's going to be dash x, backslash x. Except it's not going to be backslash x because this is how x moves. So it's that, but with one replaced by that. And then sine backslash x is what we're going to expect that to trace out. Let's see what that looks like. Okay, that looks like a sine wave, except it looks weird to me because it's not quite scaled. Oh, yeah, okay, so it should be times pi divided by 180, not times 2 pi divided by 180. That's why it looks stretched weird. That's more like it. And I'm going to add more than 1.4 because we don't want it to start right at the edge of the circle. So what if I add 1.6? Already I feel like I should have made some of these things into variables at the start, not that one. Okay, that's better. So now it starts there. What's not happening is it's not currently... My line is not going to my point, and that's because I've not times by 1.4. Because we should be times by 1.4 like that. And I think in order to get a correct aspect ratioed sine wave, we're going to have to times this by 1.4 as well, because we're scaling everything up by 1.4. This is probably why I should have persevered with making everything a unit circle at the start, but that looks good. Then, hold on. My dash line is now going to completely the wrong place. So where's my dash? Oh, I've just not changed the dash line, have I? The dash line, so what, 2 pi. So I need to remove that and do 1.4 times 1.4 times like that. Nearly, and then we change this to 1.6 like that. Okay, now if I was to then make this happen for every angle, I think that's going to draw a sine curve for us. I guess what I'll do is I'll make it go to 360, which is going to be that wide. And that's probably enough. We can get it to kind of yo-yo backwards and forwards, or we can get it to go there and then start again and repeat, or just run once. But because we now know, we can now work out how wide the piece of paper needs to be, because we know that that bottom one is the complete width. So it's 1.6 plus 1.4 times 2 times pi, which is 1.6 plus 2. Let's write this down. 1.6 plus 2 times pi times 1.4. So that's 2.8 times pi. And if we say pi is 3.2, because if we round up, we'll have too much paper rather than too little, which is the correct way around. 2.8 times 3.2 plus 1.6, 10.56. So if I do 10.56 there and 10.56 there, oops, not IPython, let's go back to PDF. I've got that wrong somewhere. Okay. Let's just, oops, let's go back into IPython and type the whole thing we want to work out into IPython. So 1.6 plus 1.4 times 2 times pi divided by 180 from math import pi first. Okay, 1.65. I did something wrong along the way. 1.65. Wait, what? That can't be right. Oh, yeah, it's not right. It's not 2 times pi, it's 360 times pi over 180. 10.4. Oh, right, okay, and because we're starting at negative 1.5. Okay, so, this is coming out different because I've no longer rounded pi upwards, so 10.4 should be enough. We can call it 10.5, so we've got enough space for the circle. But the reason it's not coming out right is because we start at negative 1.5, so we need to add 1.5 to this, which gives us 12. So let's make that 12 wide. Recompile that. No, not right, Python. Nice, so we've got it drawing out a sine curve. Now all I need to do is do all of these for each of the frames, for which I'm going to Google if there's a way to do a for loop in LaTeX outside of a TikZ picture. Okay, LaTeX as always is horrible. Let's just do it in Python. So let's do for I in range 361 print a frame I, and the new lines will double new line for us, and that's what we want. So if I then full screen that and copy all of these, this is going to make one frame for each degree, which I guess might be alright. Okay, so if we do that, it now does one frame for each degree, and we'll have a PDF that we can scroll through to watch what the animation will look like. Let's build that. It's going to take a while to build because it's got to draw all of these as vector images. Oh, wow, I think this might be too many frames. This is taking way too long to compile. And then if we scroll down, Ooh, I can hold the arrow key and watch it very slowly draw. And it's a bit jumpy because it's not scrolling through the pages at a constant speed, but it looks like an animation. It feels very, very slow, like we've put too many frames into this. And I want to be able to adjust that, so I'm going to have another go at getting LaTeX to do this for loop for me. Which I could do with recursion. Let's have a play with LaTeX and see if I can get it to do the recursion for me. So let's make an animation command. Let's pass in 0. Animation. Right. New counter animation. New command animation, which currently does nothing. See, it looks like I don't need an animation. I don't need a package to do animation. And I can print animation by doing the animation. So if I then do a frame of animation, there we go. And now you can do if then else, which I think I do need the if then package for. Let's see. Yeah, undefined control sequence. Whoops. Oh, I need to zoom back in. Okay, I need the if then package. Right, animation. If then else. So if equal the animation 5. So if it's equal to 5, do nothing. If it's not equal to 5, let's do backslash animation. And do we do, is it step counter animation? So that should recursively keep adding 1 to animation until it reaches 5. So 0, 1, 2, 3, 4, and 5 degrees. So if I then did this to 360, I'd get 360 frames. I might get a recursion error before then because it might have a maximum limit for how many steps, how many layers deep it can go. It looks like it doesn't, but what I can also do is if I go to 180 and pass in here 2 times animation, that should work and give me 180 frames, and then I can adjust the frame rate to be a bit more reasonable than our first attempt. Right, what does that look like? That still looks like it's going to make a very smooth animation, so that's probably good enough. I'm now wondering if I want to put some more colour in this before I make the animation. Let's just comment that out for now, and let's just do a frame 60 so it's quicker to compile, and play with some colour before we finish. So in fact it might be enough just to make the final thing red. That feels a lot more colourful already. We could make the point go around the circle coloured if we really wanted to. We could, I think I like it like this. Let's go with like this. So I'm going to, let's go for 90 frames speed up a bit, which means each one is every 4 degrees. Animation, let's build that. Okay, so that would look something like that. That looks good to me. So now what we need to do is we need to make a little Python script, I guess Python script that converts, well, it might even be a bash script. We need to write something that converts each frame of a PDF to a PNG. Each convert page of PDF. You can see I've been on this page before. If you have Image Magic installed, you can just do that. Let's see if I have Image Magic installed. Convert frames.pdf, frames.png. No. Okay, convert a single page of PDF to PNG. Okay, I'm going to work out how to do this and then come back in a minute once I've done a lot more Googling and reading. Right, so I did some more Googling and I found this Python library called PDF to image, which has a convert from path function, which loads the PDF and then can save them as PNG images. So if I run this, there is now this image.png in this folder, which has one image, which is 945 by 237, which seems, yeah, quite low resolution. So let's see if I can increase the resolution when we load the PDF. Convert from path. Does it have a doc string? It does. Okay, so it's got DPI input. So we just put DPI as 400. Let's try running that. This is 473 tall. Well, that's pretty good. Let's just put it to 600 just to make it even higher resolution. Good, that's now 2835 by 709 pixels. That seems pretty decent resolution. So let's then, for image in enumerate images, let's make a folder for them. Image slash, let's call it frame I. Right, so that should, if we run that, it should now be making this images folder. Loads of files are appearing for each frame of the animation. And now I can open these up and hold, I've already got it open, this one here. If I now hold the arrow key, no, that's a different folder. If I open this one and hold the arrow key, that's what we want our animation to look like. And that looks already quite nice. We now just need to stitch these into an MP4. So make PNG images into MP4. I'm pretty sure you can do this with FFmpeg, because I think I've done this before a long time ago. Convert PNGs to video files, that seems like what we want. that looks like that might be there. You know, I'm going to throw it in here. Import os.system. Run that. FFmpeg. What on earth does -f do? Image 2 minus folder, I guess. Folder is img. Frame rate. Let's try 25. No, f can't be. Let's just try it without -f and see what. Let's leave it at image 2 and faff with it when we need to. This since 05D, I don't know what that does. This looks better. This looks more like what we want. Yeah, I might need to pad the file names. If I put a thing in there, I can look at it on multiple lines. Video MP4 image equals frame star.png. Okay, so it's remaking all the frames. And then FFmpeg's done something. Video.mp4. Okay, I know what's gone wrong here. Is it seeing frames the frames below 10? It's seeing them as it's sorting alphabetical order, so it's sorting 4 before 40 before 41. So all I need to do here is pad 3 and write a little utility function to pad a number by a number of digits. So the output is that made into a string, and while, in fact, easier than that. Minus digits, colon, I think that will do it in one line. So let's delete all the frames. And if we run it again, it should now be called frame 001 and frame 002. So now it's in alphabetical order, they'll be in the correct order. Let's do that, overwrite that. And we have video.mp4. Nice. So that looks like an animation of what we wanted. So I will put the code I've written to write this up on GitHub, and I will put the description down, put the link in the description down below so you can find the code if you want to download this and play with it. And I guess I will edit this so that you can now watch the full animation a few times through. Thanks for watching.